Okay, guys, now we're going to talk about section 9.2b. Okay, we're going to do a two-sided test. According to the Center for Disease Control and Prevention, the CDC website, 50% of high school students have never smoked a cigarette. Tay wonders whether this national result holds true in his large urban high school. For his AP Stats class project, Tay surveys an SRS of 150 students from his school. He gets responses from all 150 students, and 90 say that they have never smoked a cigarette. What should Tay conclude? Give appropriate evidence to support your answer. Now, I want to talk about the difference between an interval and a test. You only need to compute a confidence interval when it says find an interval. Find a 95% interval. Otherwise, you're doing a test. I'll talk more about this on Friday when you guys get back, but hopefully that makes a little bit of sense. Okay, so in the first thing, what am I looking for? In your state, I want your parameter of interest, your HO, and your HA. Give me a second just to move this down. And this is the same as yesterday, so let's talk about our P. How do we know we're dealing with a P and not a mu? Well, it doesn't say average. You would see some word that says mean or average if you were dealing with a mu. So our parameter of interest, like we practiced in section 9.1, the true proportion of students, of high school students at this school who say they haven't smoked a cigarette. Okay. Our HO is our status quo or our current claim or our current truth. And right now the current truth is 50% of high school students have said they never smoke a cigarette. So we're going to assume that to be our current truth right now. Now Tay wonders if that's true. Now if you notice, he doesn't say he thinks it's less than or he thinks it's greater than. Since we see no words that give us any indication that he thinks that's more than that or less than that, our alternative hypothesis has to be HA is P is not equal to 0.50. Again, how do I know it's going to be a not equal to? I know it's going to be a not equal to when you see no indication or no word where they say we think it's more than that or we think it's less than the national average. Then we have to assume that it's not equal to. Tay's wondering if that's true, which means it could be more or it could be less. Our state is now done. Our plan, R stands for random. We have a random sample. Actually, we don't even have a random sample. What we can say is we can say we have an SRS was stated for N equals 150, I believe. Let's go up and double check though. What is an SRS again? An SRS is a simple random sample. I is our independent rule. We already did this in our previous video, so I'm not going to write it over here. Our independence rule is 10N, so 10 times 150 has to be less than capital N. Does it give us a capital N? Does it tell us how many people are at his large urban high school? No, it doesn't, so we're just going to say all students. Now our N, again, how do we know if it's going to be N is greater than or equal to 30 or if it's going to be N times P? We know it's N times P because we're dealing with a P. Okay, so 150, we know our P now. Before we had to use P hat because we didn't know P, but we know P, it's right here. It's 150 times 0.5 is greater than or equal to 10. And then 150 times 1 minus P is greater than, oops, sorry guys. And I need to make my little line, sorry, I'm not using a math type. Okay, so we have a random sample, independence condition suffices, and then our normal condition is okay. We are okay to proceed. We do have to state our method. What method are we going to use? We have one sample we're dealing with. We're dealing with a test, a z-test for P. Now we're at the do part, and I'm going to go to the board. I'm not going to write on the side because I've already done that. It's the same as before. There's only one little thing that's going to change, okay? So I have my curve. in my curve is always whatever the null hypothesis is. So in this case, it's p is equal to 0.5. My standard deviation, a friendly reminder, if you forget, you go to your formula sheet. You think to yourself, what am I dealing with? Am I dealing with one sample or two? I'm dealing with one sample. I'm dealing with a proportion, okay? And so I use that formula. I go back. I say my standard deviation is then p, so 0.5, times 1 minus p, divided by 150. I then go to my calculator. I need to calculate this out. So I take 0.5 times 1 minus 0.5 divided by 150, excuse me. And I take the square root of that. And I get 0.0408. Okay, next I have to figure out what is my p hat. So I have to go back up to my problem. Remember, your p hat is always going to be that part over the total. Well, 90 of 150 is my p hat, okay? And 90 divided by 150 is equal to 0.6. So right now we do have evidence that taste school is different than 50%. Our question is, though, is it significant evidence? Okay. Or is it just like natural variation? Where do I put 0.6? Well, 0.5 is right here, so 0.6, you can just pick an arbitrary point. It does not really matter where, like how far on the curve. Just gonna make your best guess, okay? So p hat is 0.6. And now because I'm on this side, I am going to shade over here. Now here's the difference with a two-sided test. A two-sided test is not wondering if it's greater than. It's wondering if it's greater than or if it's less than. So with a two-sided test, you do have to pick, approximately symmetric, the same area over here. You have to put it on this side. Because we're wondering, is it greater than or could it be less than as well, right? A not equal to means just different from 0.5. So when you're drawing your curve, what do you need to know? You mark your p, you mark your standard deviation, you get your p hat, and you shade it, and then on your curve you have to shade the other side as well, okay? What do you need now? You need a z-score. My z-score is going to be equal to 0.6 minus 0.5 divided by my standard deviation. So let me do that now. That gives me a z-score of 2.45. Once I get that z-score of 2.45, I then need to go to my charts. Or you can use your CDF, guys. But so with 2.45, 1, 2, 3, 4, 5 is 0.9929. So this p-value right here, 0.99, oh dang it, I forgot, it's 0.9929. Okay, so this has a z-score of 2.45 and a p-value of 0.9929, and because it's shaded to the right here, I need to do 1 minus that. 1 minus 0.9929 equals 0.0071. Okay, now here's the catch. Whenever you have a two-sided test, meaning you have a not equal to in your alternative hypotheses, you have to take your p-value and you have to multiply it by 2. So that actually gives me a p-value, in this case, when I multiply it by 2, of 0.0142. That's my final p-value. All right, now we have to conclude. As I'm going, remember you should be pausing along the way. Hopefully you're not getting frustrated that I'm going too fast. You do have the ability to pause and write things down and go from there. I also would expect that you are writing down any questions that might come up so I can answer those in class. Okay, so we're going to change that around to stay consistent with 9.1 when we conclude. We have a p-value. We're going to link it to alpha. We're going to make it a little more sophisticated. And then we need to make a decision about HO. So we're going to say, because our p-value, which is approximately 0.0142, is less than alpha equal to 0.05. Alpha is always 0.05 unless they state differently. We reject our H naught, our null hypothesis. So our null hypothesis, we can call it HO, H naught, or just the null hypothesis. We reject HO. What does that mean then? We have evidence for HA. So that means we have evidence for HA. Well, what is HA? HA is right here, and that's the true proportion of high school students, I should have put in there, at this school who say they haven't smoked a cigarette. Okay, so here's our HA in context, and we just have to say the true proportion of high school students at this school who say they haven't smoked a cigarette is not 0.5. Okay, again, in a nutshell, when p-value is less than alpha, we reject the HO, period. We have evidence for HA in context. If our p-value is greater than alpha, we fail to reject the HO, period. We have no evidence for HA. Quick little side note, when performing a two-sided test, you can use a confidence interval to support your conclusion instead of a p-value. And I'm going to talk about that next. Also, you don't need to interpret the p-value unless they say. What do I mean by interpreting the p-value? That's the probability of getting a statistic as extreme or more extreme than what we calculated given the null hypothesis is true. That's from section 9.1. I want to quickly talk about that confidence interval real quick, and that's with this problem. The germination rate of seeds is defined as the proportion of seeds that, when properly planted and watered, sprout and grow. A certain variety of grass seed usually has a germination rate of 0.8, and a company wants to see if spraying the seeds with a chemical that is known to change germination rates in other species will change the germination rate of this grass species. They sprayed 400 seeds with the chemical, and 307 of the seeds germinate. This produces a 95% confidence interval for the proportion of seeds that germinate is 0.726 to 0.809. Suppose the company conducted a test HO, P is equal to 0.8, against the alternative HA, P is not equal to 0.8, using alpha 0.05. Use the confidence interval to determine whether this test would reject or fail to reject the null hypothesis. Explain your reasoning. So let's talk about this. Let's look at the null hypothesis. The null hypothesis right now is 0.8. That's what we believe to be true right now. We're trying to see if it's not 0.8, okay? Does it change that germination rate? Well, what do you notice about 0.726 and 0.809? It contains the null hypothesis. The null hypothesis is in here. That means it still could be the truth. It still could be the true germination rate. We don't know exactly what the true germination rate is for this chemical, but we know with 95% confidence that it's somewhere between this lower bound, 0.726, and this upper bound, 0.809. So right now we have no evidence that it's HA. Well, how do we state this then? We would state because our 95% confidence interval contains P equals 0.8, we have no evidence that P is not 0.8. That the true, we should say it in context, the true germination rate for this chemical is not 0.8. The null or the alternative hypothesis. In a nutshell, when you are using a confidence interval to reject or fail to reject, here's what you need to do. You need to look at your confidence interval. If the interval contains your null hypothesis, we fail to reject the null hypothesis. We have no evidence for HA. If the interval doesn't contain, we reject the null hypothesis. We have evidence for HA. Give me 1 second to make this a little smaller. Not bigger, smaller, excuse me. Okay, so what should I have gotten here? Because our 95 confidence interval contains 0.8, we have no evidence. We should have put we fail to reject HO. We have no evidence that the true germination rate for this chemical is not 0.8. So again, our interval contains the HO. So because our 95% confidence interval, and you have to have that 95% there, contains P is equal to 0.8, that null hypothesis, we fail to reject HO. We have no evidence the true germination rate is not 0.8. All right, it says, find the p-value for the test described in Part A. You do not need to present a complete significance test. Explain what the p-value measures in context of this problem. Okay, so if we need to find the p-value, that means we need a z-score. Okay, so I need to go to the board. We know what our z-score is. We know that it's, or we don't know our z-score yet, but we know what our p-hat is. Our p-hat in this case would be 307 divided by 400. Okay, so then what I need to do is I need to find that as a decimal. So 307 divided by 400 is 0.7675. So on my curve right now, we assume that it's 0.8, right? Okay, then I have my standard deviation, so 0.8 times 1 minus 0.8, divided by our sample size of 400, and we get, we have to take the square root of that. We get 0.02. So I did 0.8 times 1 minus 0.8 divided by 400, because that's my sample size, and I took the square root of it. Now I'm going to quick calculate it again, because I'm going fast, and I don't want to make a video based off of a wrong answer. And I did get a standard deviation of 0.02. We have our p-hat here, 0.7675, so that's below 0.8. Since it's below, I'm going to shade to the left. I'm going to go to my chart. Before I go to my chart, though, again, I'm going fast, forgive me. I'm going to find a z-score. 0.7675 minus 0.8 divided by my standard deviation. So 0.7675 minus 0.8 divided by 0.02. And I get negative 1.63. So the z-score right here is negative 1.63. And because it's a two-sided, I'm just going to shade over on this right-hand side. And now I need to find a p-value. Do I need to subtract from 1 when I go find that p-value? Well, I'm at negative 1.63. Negative 1.63 is 0.0516. 0.0516. Now, do I need to, again, do I need to subtract from 1? No, I don't need to subtract from 1. Why? Because that p-value is a less than right here, or that z-score is a less than that we found. Now, the only thing I need to do is I need to multiply this by 2, okay? So 0.0516 times 2 gives me a p-value of 0.1032. And now it says, explain what the p-value measures in context of this problem. It is not asking you to draw a conclusion here. It is asking you what the p-value is. So in this case, for that p-value, the p-value is, this is the probability of calculating a statistic as extreme or more extreme than our p hat equals 0.7675, given the null hypothesis is true. So given that the true germination rate is 0.8. Again, that needs to be memorized. I can't stress it enough. All right, I have gotten through everything that I need to get through. I know that's a lot of notes, a lot to get through, but hopefully you have plenty to keep you busy on these 2 cold days that you have off. What are the expectations? I will write them in the update, but just know that you need to be working on 9.2a worksheet and 9.2b worksheet. At the bare minimum, if you're stressed and have just tons to do, these 2 videos must be worked on, as well as just starting the worksheet. I'll go through questions with you guys on Friday. Thanks so much, guys.